Alright, so in this video we're assuming that steam has 3 translational degrees of freedom and 3 rotational degrees of freedom. We want to know what the molar specific heat of steam at a constant volume would be, and we want to know if that matches the specific heat provided in the table in the textbook. So I'm going to take my relationship that the molar specific heat at constant volume equals the degrees of freedom times the ideal gas constant divided by 2. So 3 there and 3 here equals 6. So I'm taking 6 times 8.31 joules per mole Kelvin divided by 2 to get this molar specific heat at constant volume. Now I'm taking the specific heat that's provided in your textbook, and I have to convert it from kilograms to moles. So I'm going to do that by multiplying by the molar mass. But I have to remember, when I look up the molar mass, it's given in grams per mole, so I have to divide by 1,000 to convert it to kilograms per mole. And how I got the molar mass of the water is, because steam is the gaseous form of water, is, remember, it's H2O, so there's 2 hydrogen and 1 oxygen. So I'm adding the molar mass of oxygen to 2 times the molar mass of hydrogen, which gives me 16 plus 1 plus 1, which is about 18. And then, as I said, to convert from grams per mole to kilograms per mole, I'm dividing by 1,000. This gives me molar specific heat at constant volume of this, so they're close, but they don't quite match up, and this is where you see these ideas of partial degrees of freedom.